Renaissance astronomers described the solar system as a giant clockwork mechanism in which a series of cosmic interlocking gears determine the movements of the planets. But we now know that the orbits of the planets are not as fixed as they appear.
It seems so steady. It seems like it is this clockwork, but there are ways in which it can be disrupted quite dramatically.
Even a slight change in the Earth's orbit could severely impact our ability to survive, since the position of our home planet makes it uniquely suited for life.
The Earth seems to be an ideal planet in terms of habitability because it lies at just the right distance from the sun, in which point liquid water can be stable on our surface. We can have oceans and lakes and rivers, and we think that water is really the key ingredient for life.
Earth is in that special zone. It's not too cold, nor too hot, it's just right. If we were closer to the sun, we might end up like Venus, a planet too hot to live on, with a temperature hot enough to melt lead. On the other hand, if we were farther away, we might be more like Mars, which is just ridiculously cold, and you can't support life when you're too far from the sun.
But what would happen if Earth's delicate balance were disturbed, so that it was no longer this perfect distance from the sun? Far beyond our solar system, there are planets wandering through the galaxy, not bound to the gravity of any star. Known as rogue planets, they were ejected from their birthplace by unstable orbits or cosmic collisions and sent on wild trajectories through the universe.
Essentially, a rogue planet is a planet that was originally in a different star system, and it was kicked out and is now wandering the cosmos, divorced from its parent star.
There's likely to be at least as many planets as there are stars. So we expect there's something like 100 billion stars in our galaxy, and so we expect a couple 100 billion of these rogue planets.
These rogue planets are interstellar nomads, cold, devoid of life, and careening through the darkest reaches of space. And many of them are likely to be giants, hundreds of times larger than Earth.
Right now, we're seeing more so-called Jupiter-sized planets than others. Based on that, you could expect an average rogue planet to be on the order of a Jupiter-sized planet, maybe less.
With billions of rogue planets in our galaxy, it's possible that one could swing through our solar system with monumental effects.
A rogue planet coming into the solar system will probably be moving at hundreds of miles per second.
It's possible that a rogue planet could hit the Earth directly, completely demolishing our planet. But a rogue planet would not even have to get near the Earth to create havoc.
The nightmare scenario is that one of these large rogue planets drifts right through our solar system and ends up disturbing the orbit of one or more of the larger planets. And because these larger planets, like Jupiter, actually help shepherd the inner planets, it ends up elongating the inner planets' orbits, which would dramatically change things for life on Earth.
It's almost like taking a baseball bat to the Earth, the rogue planet being the bat, and just the force from this planet will be so great that you just change the path of the Earth just in the same way that a bat can change the path of the baseball on its way to the catcher's glove.
And if Earth's orbit were elongated just enough to swing outside the habitable zone, our very survival could be at stake.
The habitable zone, as we understand it in any star system, is defined by what we call the triple point of water. You find water in all three phases: liquid, solid, and gas. And so far as we know, you need that in order for life to be able to survive. And when you start making Earth's orbit more elliptical, you start touching the fringes of this habitable zone where it could be a little warm for all three phases or a little cool for all three phases. We're still there, but it doesn't take much to shove a planet's climate over the edge and either make it a super hot Venus or lead it to a very cold Mars.
Since there has never been an encounter with a rogue planet in recorded history, scientists are unsure of how the event would play out.
So we really can't know with great certainty what is going to happen if a rogue planet comes into our solar system. We can run computer models, we can make educated guesses, but at this point it's a purely hypothetical phenomenon.
Here is one possible scenario. A rogue planet suddenly appears on the fringes of our solar system. As the rogue streaks past the outer planets, the whole solar system begins to change. The rogue's gravitational pull alters the orbit of Jupiter. Jupiter, in turn, pulls the Earth out of its nearly circular orbit to an elliptical orbit.
If it passed near the Earth, then the Earth's orbit would be changed almost instantaneously.
This new orbit takes the Earth as close to the Sun as Venus and as far out as Mars. Although we still remain in the habitable zone in this new elliptical orbit, our climate would begin to alter drastically. For most, the change is so gradual that at first, it's hardly noticed. The days grow longer and the nights get colder, but life goes on as before. But over the next few months, a slow-motion global disaster begins to unfold.
There's a common misconception that the Earth's seasons are driven by our distance either toward or away from the sun, where summer is when the Earth is closest to the sun and winter is when it's farthest away. That's not true. Right now, it's the Earth's tilt that causes summer and winter. So when your side of the planet's facing toward the sun, it's summer. And when your side of the planet's facing away, it's winter.
The entire planet would have summer at the same time because it's very close to the sun, and then the entire planet then experiences winter at the same time when you're farthest away from the sun.
So the Earth would enter a new climate phase where you would have short but intense summers and then very long winters.
So life on Earth is very much dependent on the orbit we are in around the sun.
The shift in our seasons would wreak havoc on Earth's agriculture, resulting in a shorter growing period and eventually mass food shortages.
The effect could be very dramatic and really affect the prospects of life on Earth. If we're very unlucky, it could end life on Earth.
As the climate catastrophe continues, the Earth struggles to adapt, and the worst is yet to come. Imagine that a rogue planet has suddenly passed through our solar system and alters the Earth's orbit. A new elliptical path draws us closer to the sun, and a climate catastrophe ensues. World temperatures would increase dramatically. Runaway global warming causes ice caps and glaciers to melt, raising the sea levels around the world by 3 feet or more.
Now, 3 or 4 feet of sea level rise may not seem like a lot. Let's think about Lower Manhattan, New York City. It's protected by a seawall, which is about 5 feet high at average tide, and at high tide, the tide is about 2 feet below the top of that seawall. Now, if you're adding 3 or 4 feet on top of that, now you've got the ocean in New York City, in the subway system, and the financial district without a storm even being present.
With just a few feet of sea level rise, you have a lot of problems because most of the major cities of the world are built on or near the ocean. And they're designed with infrastructure such as subway systems, for example, or sewer systems that are not designed to handle more than a foot or two of sea level rise. And so when you have those first few feet, it causes major costs. But then when you go beyond that, you're talking about cities literally disappearing off the map. But if we warm the planet significantly more, let's say 10 degrees, then you're talking about all of Greenland and all of Antarctica melting. When they're all melted, you're going to have 250 feet of sea level rise, which is literally wiping most of the major cities off the map totally.
With much of the coastal areas flooded, hundreds of millions of people would be forced to move inland, away from the ocean and the rising temperatures.
Basically, all the habitable areas as they are now would tend to shift away from this increasingly hot equatorial region up north to preserve the way of life as we have it.
The migration would tax life support systems and stretch government infrastructures around the world to the breaking point.
One of the biggest impacts that a big climate change or a shift like that would cause is agriculture would stop. Food is effectively governed by a seasonal pattern that we take for granted. And if that goes away, then you can imagine a scenario where we don't have enough food to feed the population, economy breaks down, and that would actually become more dangerous to society than the actual climate change that we would experience.
But the worst is not over. Environmental effects from a rogue planet would continue to be felt across the globe.
It wouldn't be just one area of the planet which would be affected by these sorts of phenomena. The whole planet would suffer during the summertime when the planet was closest to the sun. You'd have incredible heat waves, incredible droughts over the entire planet.
More areas become arid, with large sand and dust storms blanketing cities and making it dangerous for people to leave their houses.
You might find entire populations walking outside with respirators on all the time just because it's so dusty.
And temperatures of 140 degrees would threaten our very survival.
Once the temperature reaches 130 degrees, you can't survive that. You can't sweat fast enough to cool your body. And if you're outside without air conditioning, then you're just going to die.
And with the Earth's orbit altered and the planet closer to the sun, deadly wildfires are just a lightning strike away. Massive firestorms would devastate thousands of square miles of forests and grasslands.
You're going to have problems not only with drought, you're also going to have wildfires, because any vegetation that's cooking in that kind of heat is going to be highly dried out and subject to bursting into flame.
But it's not just extreme heat that threatens us. It's also the cold, a new ice age, as the catastrophe continues. Imagine the gravitational impact of a rogue planet has altered the Earth's orbit, causing it to be much more elliptical. This shift would have a drastic effect on the weather. Runaway, supercharged global warming, leading to floods, droughts, widespread wildfires, and extreme swings in temperature. Ironically, the global warming caused by the new altered orbit could cause certain areas to freeze over.
One of the big misconceptions about global warming is that every place on the planet gets hotter all at once. Well, that's not true. The climate system is much more complex than that. So when you add more heat to the system, there are all sorts of feedback mechanisms that start to kick in. Like when you heat the water, it becomes water vapor. Well, water vapor makes clouds, and clouds reflect all the sunlight back to space. Well, that is going to have a cooling effect. So it's very likely that you could have areas of the Earth get much colder while other areas get much hotter. One potential effect of global warming is that Britain ices over. You have a new ice age at the same time that you get massive droughts in the US.
Some scientists fear that global warming could also lead to a shutdown of the thermohaline circulation, a giant conveyor belt that distributes warm and cold water around the globe.
Think of it as a tractor in the ocean that's carrying cold water from the Arctic and forcing warm water up from the tropics. And what that does is it cools down the equatorial region and heats up the Arctic.
Now, if that circulation were to change because of the substantial differences in Earth's orbit, then you would have a situation where Europe would have a much different climate, and North America as well, because a lot of heat gets transported by ocean currents.
A shutdown of the thermohaline circulation could accelerate global warming. As the polar ice caps continue to melt, very cold air mixes with warmer air. Tropical storms could become stronger, and more frequent superstorms would be born. The constantly hot equatorial zone will produce more water vapor in the air, which could lead to larger and more frequent cyclones and hurricanes.
That's going to cause flooding when you do happen to have a situation where you've got rain falling. So both drought and storms are going to get worse with a very hot planet like that.
And if ocean temperatures were to rise above 115 degrees Fahrenheit, we could face a special breed of superstorm called a hypercane.
Now, that is a type of hurricane/tornado that gets to a wind speed of 500 miles per hour. It's been theoretically shown that if you heat up a large enough area of the ocean, say maybe 50 or 100 miles in diameter, to a temperature of 115 degrees, you could get one of these theoretical storms that go way up in the upper stratosphere and cause incredible destruction wherever they hit. A hypercane you could think of as a tornado on steroids or a hurricane on steroids, kind of a cross between the two, much more powerful than either, which would destroy any structure in its way.
This climate catastrophe projection might seem like a worst-case scenario. But if a rogue planet did alter the Earth's orbit, many scientists believe we would have something much bigger to fear. It's possible that the Earth itself could become a rogue planet.
The Earth's orbit would change by a larger and larger amount, and the Earth might eventually get ejected from the solar system and become a rogue planet itself.
The Earth itself wouldn't be destroyed, it would remain intact. But as we went farther and farther away from the sun, the surface would cool and the atmosphere would freeze, and if we had any chance of survival, we would have to dig down into or toward the mantle where the radioactive elements are keeping the Earth's core hot, and we would become subsurface dwellers in order to survive. To us on Earth, it would look like the nights would get longer and longer, the days would get fainter, till eventually it's perpetual night. And the sun becomes just a bright star in the starry night sky, and that's it for the rest of time.
These doomsday scenarios may seem like the stuff of science fiction, but with billions of rogue planets wandering through space, the threat is real. Luckily, scientists around the world are developing the tools necessary to spot these rogue planets long before they arrive in our solar system.
Disasters have wiped out the planet before.
We know that these things are a threat. We know they're going to hit again.
Nothing lasts forever. Forecasting the end. Next on the Weather Channel.
What if a rogue planet streaks through the solar system and pulls the Earth into an elliptical orbit, causing an environmental disaster? This new orbit would generate extreme weather events that threaten the very survival of the human race. In an attempt to combat this potential catastrophe, scientists are scanning the skies in hopes of detecting these rogue planets before they become a threat.
We use mainly two telescopes, one for the discovery itself. It has a very good wide field capability.
This telescope, known as the CFH, or the Canada-France-Hawaii Telescope, is located atop the summit of Mauna Kea in Hawaii and is one of the most advanced of its kind in the world.
And then for the spectroscopy, we went to the VLT. So that's really a cutting-edge telescope. Then you see the chemical composition. So we're not just seeing a little point moving, we're seeing really the composition of the object.
These VLTs, or very large telescopes, consist of 4 individual scopes and operate at both visual and infrared wavelengths. They are capable of detecting objects 4 billion times fainter than can be seen by the naked eye.
So these are really massive telescopes, and they gather data, and then you spend a lot of time, usually years, analyzing the data.
Etienne and his team have been successful in finding hundreds of rogue planets, but one planet in particular stands out among the rest.
So this planet was discovered as we were looking for failed stars. It's about the same diameter as Jupiter, so a bit more than 10 times the size of the Earth.
We didn't know if there were other planets out there or if planets were common. Now we know that planets are common, and we've found more than 800 with a possibility of 2,000 now, and that number is only going to get bigger as our telescopes get better.
In principle, a rogue planet could enter our solar system, and if it does enter and if it comes close, then it disrupts the orbit. Of course, it can have catastrophic impacts, ultimately to wipe out the biosphere.
Fortunately, astronomers have yet to spot any rogue planets headed our way. Our ever-evolving technological advancements and understanding of space has also shown us how delicate the balance of life really is, and that our orbit, at least for now, is in a perfect position.
Here in the 21st century, we live in kind of a Goldilocks zone for life on Earth. It's not too hot or too cold here. So let's work on keeping us right in the Goldilocks zone. We don't want to move too far on either side. It's not so good for civilization and life on Earth.